Hi everyone, I am Deepa Maret. My project is about how well we can predict whether or not an individual's yearly income is greater than $50,000. I am using sparkling water to perform deep learning. Sparkling water is a machine learning platform to perform fast, scalable machine learning algorithms of H2O with the capabilities of Spark. R is used as the front end. Data is downloaded, cleaned, and visualized in RStudio. R sparkling package is used to initialize sparkling water in R. Let's go to RStudio to show you a demo. So this is the markdown document. I downloaded adult data from UCI's machine learning repository. Original data was split into training and test subsets. I combined those two datasets together and split them later after doing the cleanup. So our dependent variable is income. So here I am downloading the training set from UCI's website. Here I am downloading the test set. So here I am going to combine both data sets. So here you can see that there are around 49,000 observations and 15 variables. This data is not very clean. As you can see, there is question mark, there are some blank um, spaces. And here also you can see that when I combined, the income now has 4 levels. One level, they have an additional period there, so I have to clean up the data. So see here income, you can see that in the test data they had less than or equal to 50K dot. So we are going to make that into two factors. So in the first time, what is, I removed the final weight. This was a column. So I reduce to 14 variables from 15. Now I am removing education variable, since there is another column with education.num, which is essentially the same thing. So you can see that the number of columns is reduced to 30. Then I am reordering for my easiness. And here I am cleaning up that income variable. Now we have 4 factors. I'm reducing it to 2. See, now we have less than or equal to 50K and greater than 50K. Next, I'm cleaning up the marital status. It had many levels like married, spouse, married, CIV spouse. I simply reduced to 2, married and single. Now I am reducing the country, the native country variable, just to 2, US and non-US. This is actually reduce the levels from 40 to 2. Now, the same way, the occupation variable reduce levels to 13 here. Then the race variable reduced to 2, white and non-white. And the work class reduced to 3, just private, government, and self. And also, I also cleaned up, I didn't say that during the demo, cleaned up some empty or blank cells, and the cells with question mark and stuff like that. And this is how the data will look after the cleanup. So it has 45,187 instances and 13 variables. Here I am plotting the quantitative variables against the response variable income. So there are 5 quantitative variables: age, education, hours per week, and capital gain and capital loss. So we can clearly see that there is a difference. Now, here I'm trying to plot the categorical variables. This is just the income, marital status, native country. This is occupation. This one is race and relationship. This one is sex and work class. So now we are getting into deep learning. So we have the data set ready. The first thing, I had to load the packages rsparkling, sparklyr, H2o, and also initiating the H2o. So you can see that the connection is successful. Now the next thing is initializing a local Spark connection. And I created Spark data frame. After this is run, you can see that this is going to create a Spark data frame. It's taking time. Okay, it's done. So after that, we are converting the Spark data frame to H2O frames. Now we can, to save time, I'm not viewing the data frame, but I need to convert all the categorical variables to factors again once I got the H2O data frames. So now to train the model, I am splitting the data into train, test, and valid. 60% to the training set, 20% to the test, and 20% to the validation test. And here defining the response variable as income, and the predictors are the rest of them, all of these. Now we are training the deep learning models. First, we will train a basic deep learning model with mostly the default parameters. So it is done. Then in the next model, we will increase the number of epochs by setting epochs equals 50. The default is 10. Then increasing the number of epochs in deep neural net may increase performance of the model, but we have to be careful not to overfit. So we will use H2O's early stopping functionality later in the model. In this model, we will first turn off early stopping. So in the third one, we will use the same model parameters as the model 2, but this time we will turn on early stopping and specify the stopping criterion. Also, we will use cross validation, n false equals 3. Now it's done. Now let's compare the performance of these three deep learning models against the test data. So here the first model gave an MSE of 0.106. The second model gave an MSE of 0.105, and the third model gave an MSE of 0.104. And so we can see that definitely the error is decreased. So then there are also a number of utility functions we can use to inspect the model. In this case, the model 3, we can see the confusion metrics and score history. That is the score history, and this is the confusion metrics. And also we can plot a model over the training process. So this is the scoring history. Also, H2 has got this grid search, deep learning grid search function. So we can use this as a quicker way to find a good model instead of doing manual tuning. So first we need to define a grid of deep learning hyperparameters and specify the search criteria. So then instead of doing the cross validation to save time, I am simply partitioning the into training set and validation set. Then I am going to train the random grid. So we're using the hidden as 2 layers with two neurons, and we it's still running. I think it's completed. Once we have trained the grid, we can collect the results and sort them by performance. So here we have, 1, 2, 3, 4. So we will grab the model ID for the top deep learning model, and we will see the model performance by looking at the mean squared error. So we got a mean squared error of 0.107, not bad. But our model number 3, I hand tuned, got a lesser MSE. So this is the end of my demo. Deep learning and SparkH2o. Thank you.